In this lecture, we're going to look at using lighting in our Vertex Frag shaders. So to do that, you need to write the code to deal with all of the lights from scratch. Well, not quite from scratch, there's a lot of stuff already done for you, but basically you've got to understand the premise of the lighting model that you want to use. In this case, we're going to do diffuse, which is our Lambert lighting, which includes the normal on the surface and the position of the light source. There's no mention of where the viewer is in this particular model. So create yourself a new shader and put it on Zombunny in this case, the default one that comes with Unity from having created it from Create Shader, Unlit Shader will have a material available for you to use, and you can put Zombunny's texture on there. Now it won't look like what I've got because I've already written the code and I'm about to step you through that. So you will have an unlit one to begin with. Let's open the code and step through it. First of all, we've got our name and we've got our property of our material coming in. Next we have our subshader block with the pass, and then we have a tag in it called light mode equals forward base. What this does is set it up for forward rendering so that the lights are calculated on a per model basis. They're not calculated at the end, as is the case with deferred lighting. Next, we're going to start our CG program, and we have the usual suspects at the top, our Vert, our Frag, our Unity CG, and then we have this new one called Unity Lighting Common.cg Inc., which has definitions in there for the lighting system. And if you're going to start using properties from the lights, then you'll need to include that file. Next, we have our app data, so we need the vertex, obviously. And we're now introducing the normal because it's the normal that's the most important part in this lighting model. And then we have our texture coordinates, or our UVs. And then we have our struct for the V to F. Same stuff as before, except we're now including this diffuse value here, which is a color 0. And this is going to be the color produced for the lighting that we do in our calculation. Now the vert function is going to convert our vertices as we've done, grab hold of the UVs, and the new stuff in here are the next 3 lines. First of all, we're going to calculate our world normal, and we do that with the vertex normal, and we do our conversion of Unity object to world normal in there. So we need to use that to convert the normal that's on the mesh, which will be in local space, local to that particular mesh, into its actual coordinates in the real world, because that's the only way that you can then compare that normal against where the world position of the light is. They both have to be in the same coordinates, or the same coordinate space, I guess. Now, after that, once you've got both of those things, you can work out the dot product, as we've done before with lighting, between the world normal on the mesh itself and the world space light position. So this world space light position, you're getting out of that lighting, where is it? This lighting common file at the top. And this value actually holds on to the position of the light that's in the scene. So you've got your X, Y, Z value for it. So the dot product, or at least the maximum between 0 and whatever the dot product is, so this will be between -1 and 1, but you only want it between 0 and 1. Now, as we've done with Lambert lighting in the past, we then take our normal we've calculated and multiply that by the light color. So this underscore light color 0 is also in that include file that's at the top, and it holds the color of the light that's in the scene. So we now have calculated our diffuse color to use on the surface of our object, and so therefore we return it in our structure with all of those other values. This goes to the frag. So if we just go down to the frag, and the frag does really simple calculations here. It's getting the color from the texture, as it's always done, and then we just, before we display the color, multiply it by the diffuse color of the light, and therefore it will then render that pixel out, taking into consideration the color from the texture and the color from the light. So save that, put that onto Zombunny if you haven't already. Then if you grab hold of your directional light, and you should be able to rotate it around and see the lighting working on the surface of Zombunny because of that code that you've written. So if you took that code out and then moved the light around, you'd find nothing happens whatsoever. So this is that working. And we've also included the color of the light. So if we change the color, we're affecting the surface again with that. And that's how to add simple lighting calculations into your fragment vertex shaders.